Our most advanced product is a Blackbox Toolkit V3. This will let you benchmark and calibrate your own experiments live. So it acts as a virtual human, so it can look for the onset of visual stimuli, the onset of audio tones or speech, TTL triggers, response pad buttons, etc. And it'll log them all in real time, and it can produce responses to anything that you choose to pair the responses to. So for example, if you detect a stimulus image, you can use an active switch closure to close a switch or a button on your own response device, or you can use one of our response devices and plug it into the Blackbox V3. The option's yours, in short. So I'll run through the various sensor options. So you've got 4 optos, so that's 4 photodiodes that you can put on screen in any location you like for detecting the onsets of visual stimuli. So you could have 4 at different locations for RSVP studies where you're presenting things really rapidly in serial succession. So 1, 2, 3, 4 for 4 frames, for example. It's got 2 microphones that you can plug in that you can use to monitor sound coming out of a speaker or a voice key triggering to make sure that the voice key is triggering on time. You've got 2 tone generators, so basically you can generate tones that will trigger your own voice keys, or you can test how efficiently your own microphones are recording the sounds and what the latencies are on that, and whether the positioning's less than optimal, for example. There's an audio pass through in and out, so basically you could take the cable from your speaker setup and pass it through the in and out. So in other words, it'll loop through the black box out to your speakers. So it's a way of triggering from the actual audio output lead. Any of the Blackbox Toolkit response pads can plug into the front here, and they'll appear on the timing that's captured, so you'll be able to compare any button down with anything else that happens. There's a turnable pot which you can press for altering the thresholds and sensitivity on all these inputs, and the LCD screen will show you what's happening as well. And you've got LEDs on the bottom here to show you what's happening in terms of in and out. So when the opto's triggered, for example, the LED here will illuminate. And then on the rear of the unit, we've got the standard breakout board, which is an 8-bit I/O board with TTLs and active switch closures on there, and there's also a button on top. That's this little board, which I'll explain more about in a second. And then we've got a 16 channel expansion port, so that's 8 TTL ins and 8 TTLs out. We've got an update port here, so you can update the firmware through there. We've got a standard USB lead, a power on and off, and the power supply, which is a 9-volt DC power supply, which will be region specific to wherever the black box is being used. So just going back to this breakout board, which is connected via a 25-way cable. Basically you've got screw terminals which you can put your own wires into for active switch closures, so that'll kind of trigger your own buttons if you clip them on the back. We've got TTL ins and outs. On the other side, it's got inputs and outputs. And we've got a button on top which is used for calibrating the robotic key actuator, which I'll show you in a sec. And that works on TTL input 1. The actual expansion board, so the 16 channel one, basically looks like that. So again, you've got screw terminals, so you've got outputs and inputs, 8 of each, and again you can wire that up however you like. So that might be to and from a digital input on an EEG machine, for example, or an eye tracker. So you've got kind of plenty of digital I/O ports. So I'll just show you one of the microphones. So one of the microphones are kind of really high spec ones, which are custom built by us. So they're a lot more accurate than standard microphones, and they basically plug in the front. So what I'm going to do is I'm just going to plug a few things in, and then we'll fire up the software so you can have a look. So what I'll do, that basically goes into, I'll just plug that into mic 1. And then what I'll do is we have a tone generator. So that's basically as described, it makes a tone when we trigger it. So I'll pop that next to it, and I'll put that into the tone generator slot. Right, so I'll plug the power lead in to the back, plug the USB lead in, and then I'll plug one end of the 25-way cable in to the standard breakout board. So that's the one with the button on. So I'll plug that in there, and again that's got a pass through. So if you wanted to use your own cable to your own device afterwards, you could pass it through there. So basically what we'll do is we'll switch the unit on. It comes out with the copyright and the date, the firmware, etc. We've got an opto on this second monitor here, so we'll use that as a trigger. What we'll do, we'll plug that into opto 1. So basically that's for detecting visual stimulus material. So you can see, hopefully you can see the microphone's pretty sensitive. So if I give it a tap, hopefully you might be able to see the LED on the front of the unit illuminate. So what I'll do is I'll fire up the actual software. So this is for programming the Blackbox Toolkit V3 and for uploading the data afterwards and analysing it. So basically there's a completely independent timer in the Blackbox V3. So it's a really accurate sub-millisecond timer. You basically program the V3, and then once you set it running, it's completely independent of the PC, so it's not interacting with the PC at all, other than the sensors are looking for things on screen with the optos, the microphones are trying to detect things, the TTLs are detecting things. So it's completely separate from your PC, and then once it's finished capturing the data, it'll upload it to your PC, and then you can check it to make sure that your timing's accurate. So the best way to think about the Blackbox V3 is a virtual human, so it can see everything that happens in real time. It logs the exact timing when things happened in the real world, and it can respond to any of those events and simulate a human. You can also do basic event marking with this as well, so you could say, okay, if I see this opto, I want to event mark on this TTL, or I want to do something else, and we'll run through doing that quickly next. The sensors can be auto adjusted, so with the optos you can put a white patch up and it'll auto adjust to the best setting for that, or you can use this sensitivity management tool, so we can basically go through and alter the thresholds, or the sensitivity in other words. So what we can do is I'll just alter the opto slightly, so it's linked, so hopefully you can see me moving the dial, and it moves on screen. So basically I'll move the rotary encoder left and right, so I'll pick the opto, and then I can up and down the slider, so that'll up the sensitivity. So hopefully you can see that going up on screen as I alter it. So I'll drop it back to the default, which is 50%. But again, depending on the hardware you've got, you need to do that to be tuned to your own hardware. Right, so that's the sensitivity done. So what we'll do now is we'll run through an actual study, if you like. So we'll simulate a human. So we'll use this thing called DASCO, which is Digital Stimulus Capture and Response. And what we'll do, we'll clear the RAM in the Blackbox Toolkit V3. So it's got its own RAM, its own timer. So it's storing everything independently. There's nothing connected to the PC that might alter the timings that you're recording. It's purely a real world timing device. So what we'll do, we'll look at the auto response generator. It's pretty simple. Basically, you've got a set of patterns that you can respond to and something that you can send out. Yeah. So what we'll do, we'll say, okay, if we see I don't know, if we see an opto in, in fact what I'll do, I'll just cancel this and I'll pull the stimulus across there, right? And I'll put the microphone next to the speaker over there. So what we're going to do is we're going to do a cross-modal style test, if you like. So I'll go back up there and I'll say, okay, if we see opto 1, so that's that opto on this other screen, come on, what we'll do, we'll wait 300 milliseconds, and then what we'll do an active switch closure and a TTL out. So basically what we could do is we could hold the button down on our own device, and we're going to hold it down for 100 milliseconds with an RT of 300, and at the same time we're going to TTL event mark all that, so that might be going into our EEG event trace. And I think what I'll do on this as well, I'll put the sounder out of the way, but what we'll do a sound as well. Yeah, so then we'll be able to hear it. And we're going to run this for 30 seconds. So basically, if we run through this again, it's if we see opto 1, so as in a stimulus image appear on screen, on this screen here, wait 300 milliseconds, and after 300 milliseconds, so that's the RT, hold active switch closure down, so that might be effectively closing the button on your own device. TTL out at the same time, so that might be going onto your EEG event marking trace, and also do a sound just so we can kind of monitor what's going on. If you don't want to use active switch closures, the other thing that you can do, which is quite neat, is you can use this robotic key actuator. So basically this is something that you can use on TTL1, and you can basically position the gantry above one of your own buttons, so that might be a key on your keyboard, one of your own response pads, or something else. Even work with touch screens. So it's a grounded foam conductive plunger, and basically you put a grounding wire in it. You can even press the screen on an iPad or an Android tablet or a smartphone. So that's quite neat if you're not keen on doing wiring. So we'll pop that on one side. So we're happy with that now. So we'll generate that. Oops, I've clicked on done by mistake. Sorry, I'll just do it again. Apologies for that. So I'll do opto 1, sounder 1, active close, TTL 1, 300, 20 times, 100 down. So then I'll program the black box, and it basically sends everything across live to the black box. So now it's going to run completely independently. So that's independently of anything I do or the PC does or your experiment generator does. Because remember, we're simulating it on this screen here, but normally that would be your experiment generator that'd be running, and we'd be looking for visual stimulus images appearing. We'd be listening out for sounds on the microphone here, and then we'd be making responses pre-programmed in the black box, fed back into your experiment, and then we compare the times that you recorded with your experiment versus the times that we fed in with sub-millisecond accuracy from the Blackbox V3 and what we recorded. So it's basically checking your experiment timing on your hardware with the real world, really accurate timing using the Blackbox V3. Okay, so what we'll do, we'll set the cross-modal simulator running at, say, 500 milliseconds. So that'll ping across, so hopefully you can see that going. You can see the mic being activated as well. You can see the opto being triggered on the front of the black box. So what we'll do, we'll set our simulator going now, and we'll see what happens. Right, so we'll just stop that cross-modal simulator, and basically if you saw, you could see the output LEDs on there. So as things were triggered, the output waited so long, i.e. 300 milliseconds, and then triggered the button down, or the ASC in other words, TTL out, and the tone generator for 100 milliseconds. So basically what we can do now is we can look on the spreadsheets and we can see what the opto duration was. So in other words, how long was that image displayed for? So it should have been displayed for 1000 milliseconds, but as we can see, it wasn't, which again is what you'd expect. So some were nearly 1000 milliseconds, some weren't. And again, what we can do, we can look at the audio duration. So that should have been 250, but as we can see, that was over as well. Yeah. So again, the audio should have been synced with the opto onset. So we can see that they weren't synced as well. So in other words, on this little simulator, everything should have appeared at the same time, but we can see that it didn't. So basically, the opto is much, in this case, later than the audio, which is the reverse of what you'd probably expect, unless you checked it. So we can see that that's quite a bit different. So it's about 50 odd milliseconds difference. So again, without this equipment, you wouldn't know that you got an error, and you wouldn't know that your event marks were out as well. So basically your digital event marks would be incorrect because you actually triggered them at the wrong time. So what you could do is you could either move one stimulus material forward in time or backward in time, and then rerun this so that everything was aligned, if that makes sense. And then your event marks would be bang on. But without using this, you wouldn't know. See, you would assume that everything was generated at the right sort of time, and that would be the case with any experiment generator they use, whether it's our little simulator here or whether it's a commercial experiment generator. You can do a lot of other neat things with this as well. So you can export the data, and again you can drag things around. So you can look at any 2 points in time. So you can look at, say, the onset of the opto to the onset of the microphone. So you can see that it's 69 milliseconds difference. So the audio was actually forward by 69 milliseconds. So you'd have to either pull the visual stimulus forward or pull the audio back. Or what you could do is you could insert 69 milliseconds of silence onto the front of the audio that you played. Yeah, so that would be one way to realign it, if that makes sense. And then you've got the other output, so you've got the sounder there, the TTL out or the event mark, and the active closure, which might be one of the buttons on your own response device, or that could be the plunger pressing down on the robotic key actuator. So that could be that pushing down on your own response device or on your iPad screen or your Android tablet screen. Right, so hopefully that gives you a flavour of how the Blackbox Toolkit V3 works and how you can use it as a virtual human to calibrate and to correct any errors in your own experiment that are down to timing or equipment or errors in the experiment generator that you're using.